Welcome back to another video. We're still talking about the various transformations we can do to linear functions. And in this video, we're going to be looking at reflections across the x-axis. I'll be posting videos for every type of transformation, the two different reflections, shrink and stretching. And so if you haven't looked at those, please check out the playlist. So let's get started here. Again, a reflection is a rigid transformation that flips the graph over a line of reflection. And in this case, the line of reflection is the x-axis that is highlighted here in black. And so if we're looking at this, this red line here, if we look at this point on the red line, since we are flipping it across the x axis, if we stay with the same x, we should get the opposite y in sign. So we flip from, let's say here, +7 to -7 right here. And we stay on the same 5. That's the point of a flip around or across the x-axis. In the negative numbers, we have the same thing here. We're going to flip, say, from y equals -5 to y equals +5, and we stay with the same x value of, looks like 7.5. So when we do a flip across the x-axis, what we're saying is that we're looking at the same x for the opposite y. And so the formal transformation is f of x goes to minus f of x, or negative f of x. So in this example here, the red is our original function. F of x equals x plus 2, and h of x is our new reflected function. H of x equals negative f of x, which is equal to negative, in parentheses, x plus 2. So we're putting a negative sign over the entire function. And that's what we would do for any general function that we would like to reflect, not just for the linear function. So as a reminder, the reason we're doing this is because we're trying to generate from one parent function, which is the simplest form of our family of functions, the entire set of functions that are similar to it. So in this case, we're looking at linear functions, and so the parent function is the simplest, most basic linear function, which is just f of x equals x. In the image, I'm starting with a slightly more complicated linear function that does have a non-zero intercept of 2. Okay, so how do we see that this actually works? Well, let's see what happens when we draw a table. We have x, f of x, and then h of x equals minus f of x. So if we take x equals, say, 0 here, our f of x is 2, right? 0 plus 2 is just 2. H of x is negative that, so it's negative 2. And if we look here, indeed, we intersect the y-axis at 2, and the h curves intersect it at -2 here. Let's take another example. Let's look at what's happening at, say, x equals 2 here. So when x equals 2, we get f of x is just 2 plus 2, which is 4, and h of x is -2 plus 2, so -4. So if we look here, indeed the red curve, or the red graph, is 4 when we are at x equals 2, so we have 2, 4, the ordered pair. And then if we go down here to the blue, we see that we do get also to -4 for our blue curve, which is our reflected curve. We can also do this by looking at the actual reflections, meaning looking at our y component and determining from that what the x would be given our two functions. How do we do that? So we can look at our y value and then figure out what our x value is from f of x, and our x value if we assume h of x. Okay, so let's erase what we have going on here so it's a little clearer. Okay, so now let's look at that in green, say. So let's look at the point 3 here, y equals 3. We'll make a line across that cuts through both functions. So this is our original function. Where does it cut through? It cut through at x equals 1. On the other hand, here with our blue function, which is our reflected function, we get the cut at -5. So we have 1, 3 for this point, and we have -5, 3 for this point. Let's see what comes out from our functional form. So we say y equals 3. What do we get for f? Well, f is x equals to x plus 2, so we have 3 equals x plus 2. Let's subtract 2 from both sides, and we get 1 equals x, which agrees with our finding here. What about h of x? Well, we get 3 equals -x plus 2. Let's multiply by -1, so we get -3 equals x plus 2. Let's subtract 2 from both sides, and we find -5, right? -3 minus 2 is -5 equals x. And again, that agrees with what we found graphically. So we can go in both directions and prove that that is really our reflection. So to recap, when we want to reflect across the x-axis, we will find that our new function, h of x, is equal to the negative of our original function, f of x. And that is true for linear functions, but also for any type of function. So this demonstrated the reflection across the x-axis, and I hope you take the time to look at the other videos dealing with the other transformations. So thanks for joining me, and I'll see you next time.